Okay, so I wanted to add this short video just to cover a bit of a problem really with the DO2 simulation model. Some of you may have already encountered it, and I noticed it when I was testing the sample building. There's a bit of a limitation on DO2, which is when the number of shading surfaces exceeds 1024, it will fail to import or export the file. Now, I was hoping that they would have fixed this by now, but it appears not. So there is a bit of a workaround, so I'll just talk you through that. So here's the sample building in Revit, and I have copied and pasted it into our site like that, and as you can see, I've just activated the crop box, section box, sorry, here, just to limit what we can see of the model. Okay, go to our Analyze tab here, and we'll just have a quick look at our energy settings. Okay, complex with shading surfaces. I know a few of you had a few problems where your ground plane was perhaps not set right. The thing to bear in mind is that the Revit will consider anything below the ground plane as a basement, and that's the same when you're doing conceptual analysis, and as such it will not put windows in the conceptual model. Similarly, for a building model, it will consider those spaces as basement levels. So just check you've got your ground plane in the right place. Okay, we just click on our topo surface here, our pad. Not very helpful. I was going to say you can check over here that you have that set at the right height, but because this ground pad was created a long time before the building was in place, it's not set to a level as such, it's set with an offset. So let's just go ahead and change that to level 10, just check that that still works. Okay, so that's done now, and as you can see, it actually made no change to the model because it was already set in the correct place. Okay, we just want to watch for that. Right, so if we now go, let's save that actually. Now what we'll do now is we'll show you what happens if you go to export, to run the energy simulation now. I think we will encounter the problem where we have too many shading faces. Okay, so let's just run that. I've tested this already, I'm sure we'll get the error. Okay, so asking us what do we want to do. We use an existing, let's just call this test 1. Okay, continue. And I would expect to get the error message now on export. Yeah. Model contains 1079 shade surfaces, which exceeds the maximum allowable limit of 1024. Okay, now what you might think is simply a case of simplifying some of the geometry, but I know what happens in practice is even if you go in and start deleting shades, you will probably still get the message, because if we consider any window, just zoom in on a window here, let's go to 9 so you can see that a bit better. on any window, all of these elements of the wall, of the window frame, will all be considered as shading faces. So it's very difficult to get that complexity out of the model. So it's a bit of a, it is a bit of a frustration at the moment, to be honest. As I've said many times, the software is all changing, and you would expect that they would get this problem sorted out by the next release. Okay, so I did try with this model going back in and deleting out shading surfaces, but it didn't make any difference. And look, when you look on online forums, it appears most people have the same problem. So what we're trying to do, we want to run the energy simulation, take that into our to the results and compare website up here, which we've used before. Click on that. So you see here's the successful energy simulation which I've run on the building before I placed it into the site. Okay. So those were the two. I ran it 3 or 4 times actually. But, so it exported successfully, but not on the site. And I mean, you may find actually that for your purposes, you may be quite happy just to run the energy simulation without the building in the site. Although it's a bit frustrating because you would like to just run it from the site. Okay, so I'll now go through the process of running the energy simulation through a slightly different way. So what we will have to do is use an export function and then import the file into Autodesk Green Building Studio. Now if we just have a quick look at Green Building Studio, there's the web address, gbs.autodesk.com. That will take you through to GBS, and you need to log in as usual, and it takes you to your project area. And in a way, if I go back to Revit, it's very similar to, under the Analyze tab, to your results and compare, which really all it does is takes you to a slightly different web interface of Green Building Studio. Okay, so there's the interface for your results and compare, which you've seen before, but it really is using the same system as Green Building Studio. So let's go back to Revit. So there's our model, and now we need to export the energy file. Check our energy settings. Okay, so location, yes, building type, let's just go with that. So it does mean that we are exporting, and as I've said before on this course, generally what I've been trying to show is integrated software where you don't need to import or export, but unfortunately in this occasion you do have to export because of this problem with DO2 with the energy simulation engine. Okay, so anyway, it would be a similar process if you wanted to export your energy model out to Ecotect, for example, or any other energy package. This is what you would do. So it's quite simple in Revit. Go under the Revit button at the top here, and export. And we need to export a GBXML. Okay, and here we have just a summary of our energy settings, and we have a preview of our energy model here, which you can zoom pan around. And what it's showing you is that these are the spaces that will be exported as a GBXML file. Look under details here, under this tab here, and you have the details of your model. So in this instance, what we're exporting is the rooms, although they are exported as spaces. And you can just check here that you've captured all your rooms. Okay, that looks all very well. We can switch to analytical surfaces, which will show the surfaces rather than the spaces. Just wait for that. Thought it crashed, but no. So by going to analytical surfaces, it's just showing us the surfaces that the energy model will be considering. Let's just switch it back to rooms. Okay. Right, so we're ready to go. So we'll go back to our general tab here, and we'll hit next. So it's exporting document, and let's just check where we're putting it. Okay, so that's fine. We give it a logical name, obviously, and hit save. Now that should have exported the GBXML file. Let's just go and look for it. Right, let's go to Green Building Studio, and these are our existing projects. Let's create a new project. So let's give it a project name. Let's call it University Mixed Use Building. Building type. School or university. Schedule. Just leave it as a default. Because if you hover over that eye, the information, as you can see there, is based on the building type. So as a default there, you could change it if you wanted. It's a test project. Project notes. Let's just call this. Let's just say cafe and academic. Continue. Asks for a location. Sheffield. Okay. Okay. So there's a map. Okay, there's our location. It's not going to make any difference because it will pick up the nearest weather station, the nearest weather files it has. So let's just leave that based in centre of Sheffield. Project address, square, latitude, longitude, time zone. Well, it calls it Casablanca, but that is the same as London. Currency, UK pounds sterling. I believe you can change the currency. It would appear to be correct, so we leave it alone. So the weather station, you can change that, but it by default uses the closest one, so we will leave that alone. We'll hit continue here. You do need to get some of this right when you create the project file. If you a bit irritating, but if you don't get things like the currency right, can't actually change it later. Okay, so what's this? I just want some confirmation. Okay, that's alright. Go to look at the project defaults here, and so project name, building, some settings here in terms of PV, spaces. I'm not going to change any of these. I'm going to leave it to use the default. But if you wanted to get into more precise, you could be setting the actual figures here in terms of the operational parameters, zones, surfaces, openings, HVAC, and stick hot water. We'll just leave that as the default. Okay. Right. So, project has been created. Right. So we created the project, but we haven't imported the GBXML file. So we go under the actions, go under run charts first of all, under actions here, and we should be able to upload the file. So we'll browse the file in our XML file. Okay, save run as, yes. Yeah. Okay, let's go ahead and upload. Right. As you can see, it's busy calculating. Okay. So it's finished that. Now, there's quite a lot to see in Green Building Studio. It is a little bit more in depth than the interface from Revit. First thing you notice is, although it's done its first set of calculations, it's busy calculating away here. You see these bars are moving. Now, as it says here, running DO2 simulation. So what it's doing is, on Autodesk's computers now, not on your own computer, via the cloud, it's busy calculating a series of what they call alternate runs. So, in essence, what it's doing is it's taking your design that you inputted, and it is running some alternate runs for this building. And so if you look, for example, here we have the first one here. It's running the same model, but it's changed the orientation by minus 135 degrees. Now, normally, you may not have the option of changing the orientation of your project, but what it does for you is it just goes ahead and does some calculation. If we look a bit further on, it changes some of the settings in terms of the performance of the glass, for example, insulation levels, skylights, and there is quite a lot to take in there, but I won't dwell on that too long. So basically what it's saying is, okay, here's some options. If you change the lighting load, so for example here we have, oops, sorry, just jumped. We have different lighting loads. It's recalculated to give you some options. Okay, so these are all different alternative buildings essentially, and you should be able to just minimize all of those. So those are useful, but obviously there's a huge amount of data there, And first of all, let's just minimize that, and let's look at our design as we imported it. Okay, so there's our unchanged design, and we've immediately got some information here. What's the floor area? Energy use intensity, megajoules per meter squared per year. Already some information. What's the cost of electricity? Fuel cost. Here's some total annual costs and some total annual energy usage and total carbon emissions in megagrams, which I believe is a ton. Sounds about right. Okay, and there's some potential energy savings. We'll come to that in just a minute. Okay, let's click on our base run. Let's have a look at that. So that immediately then takes you into another set of analysis. And as I say, there is quite a lot of detail here. So, energy, carbon and cost summary, annual energy cost, life cycle cost, CO2 emissions, and it gives you, this is an American product, large SUV equivalent. So that's one of these big cars, big sort of Jeep things, equivalent. Energy use intensity, the life cycle over the lifespan of the building, and if you hover over the little eye here, there's a 30-year assumed lifespan. Okay. Design alternative, we'll just leave that for now. Here's some carbon emission. Base run, on-site renewable potential, natural ventilation potential, on-site biofuel use, net CO2 emissions. Okay. Right, that's in terms of carbon footprint. And some energy analysis here, fossil here, which is so projects outside the US is based on carbon monitoring fraction data, so there's some assumptions there. It'll be a bit too in depth, to be honest, for our purposes. Okay. We then here have another tab. We can maximize that. Let's scroll right there. So we have a lead daylight analysis, and you don't get this in the normal Revit interface. And what it's doing is it's looking at the building as a whole and saying what percentage of the building has a glazing factor, means daylight factor, over 2%. We've got 66.3%, so we would not get our LEED accreditation. So that's very useful. You could obviously go back into the design, change the window configuration, put more windows in, run the process again and see if you're achieving a better daylight factor. Have some water efficiency, we'll look at that in a bit more detail. Photovoltaic potential, so it's saying what could you potentially generate on this building, and hypothetical wind energy potential, if you would just stick a wind turbine on the top, and natural ventilation potential here, if you were to replace the cooling that it's calculating with natural ventilation. There's quite a lot of detail here. Let's just minimize that. Energy end use charts. Scroll there. We've got some annual electric end use, annual fuel end use, detailed view, breaks it down there into further detail in terms of pumps, space cooling, probably more information you need. And then at the bottom we have our building details and assumptions, so you can check and have a look at some of the figures that it is using. So here, for example, on the right, it tells us all the U values that it is using for the calculation. And these U values will be pulled from the Revit file. Okay. You get a lot of information here about the mech vent system. I wouldn't worry too much about that. That's certainly something more for the engineers, I would say. Okay. Then we have a further set of tabs across the top. And I think really the way to use Green Building Studio is to look through the results that you're obtaining and look for the ones that you feel are more useful. So for example, annual energy cost, life cycle cost is quite an easy one to consider. The annual energy usage, the energy use intensity per square meter is a really key factor. And obviously the CO2 emissions is a key factor and quite not an easy one to keep an eye on. So probably what I would say is not to get too overly concerned with all of the performance figures, but to maybe compare a few key figures when you change the design, or you look at the alternatives that they calculated for you. Okay, go across the top now. We have the Energy Star tab is unavailable because it's a US parameter. Let's look at water usage. This is quite useful. And again, this is not available in the normal Revit interface. So what we have here, we've got our total water usage for the year for this building. Okay. And here it's saying we'll use about 1.5 million litres per year. And that's broken down into 728,000 litres indoor and about 700,000 outdoor. And you may question the outdoor usage, but we'll come to that in a moment. Then if we look through it, we've got, just to recap here, that it's a university building, floor area, our water price, and you could get the more accurate price information and change that, and equally your sewerage cost. And then here we have our outdoor water factors, and this one by default is a bit misleading because we're certainly not, for our site, we're not irrigating 1,000 square meters of external space. So let's just change that. Let's put that to 10. So let's assume that we have a few trees outside or a few small areas of planting. So we change that to 10 meters squared. Time sprinklers, yes, no. Do we have a swimming pool? No, we don't. Any other equipment? No. Let's just go back over here to our estimate button and let's just recalculate. See, everything's gone grayed out up here because I've changed the parameter. It needs to re-estimate. So let's just rerun the estimate. Okay, so it's recalculated it, and we have a huge reduction in our outdoor water usage now. So it's important to get that one right, or you get some very odd figures. Okay, let's just scroll down a bit. What we've then got is, which is very helpful, it's looked at the building and it's making a guess in terms of how many toilets do we have, how many urinals, how many sinks, showers, Clothes washers, dishwashers, cooling towers. How many have we got? Okay, and we can look at the efficiency. Okay, now unfortunately, because it is an American product, the figures come in imperial units here, so we do have to we would have to just calculate those. But let's put low flow toilets, urinal sinks. Yeah, let's put hands-free sinks, showers. Let's leave that alone. Dishwasher. We probably would have a dishwasher because we have a cafe. Okay. And let's just leave that on. Well, let's put that on as an efficient dishwasher. Okay, so we've changed our parameters inside. I mean, to be honest, you could leave that alone because it's using default based on the building type and the size, and as you see here, making it an estimate of the number of people in the building. Our figures are grayed out again. We change the parameter. Let's hit estimate again. Okay, and so it's updated the figures here. We've added in that dishwasher. We've changed some of the efficiency of the fittings. Okay, and if we look down at the bottom, net zero measures. So we're looking at what are our potential savings on this building. Now, what you might want to do here is to record the processes to save. So save where you're at, and then record the process as you change it. Okay. Right. So let's go down back again to the net zero measures, and it's pulling in the annual rainfall figures from the weather files, and it's making a guess of the catchment area based on the building. Okay. There's a figure here about it just depends on what the surface of your roof is. So we've got it as gravel stroke tar, concrete, asphalt, metal. There's a hover over it, it shows you the different efficiencies. Let's go down to asphalt, which is quite likely. And let's just switch on rainwater harvesting. So let's say that we have some rainwater harvesting on the roof. Okay. Native vegetation landscaping, well, we don't have any of that. Grey water reclamation, no, we're not doing that. Cite possible water sources, no, there's no source of drinking water on our site. So if you were to say yes, you could input what that is. So for example, if you had a spring on the site giving you fresh water. So we've changed our rainwater harvesting. So let's just have a look at the figures. So previously our total water usage was 634,000. Let's put the re-estimate. And sorry, the usage is the same. We won't change that, but because we now we're collecting water, our net has reduced down significantly because we are now collecting water on the site. And you see what it's done down here, which is very useful. Because we've switched on our rainwater harvesting, it's now estimating that we could capture about 150,000 litres of water per year based on our site. And cost saving is not huge, £100, but that's probably less important than the actual savings in terms of rather than using drinking water to flush our toilets, we can use the rainwater that we harvest from the roof. And we could have a look at this. Let's switch on grey water reclamation, and we calculate estimate, and we go down again to our grey water reclamation. Not a lot, 1700 litres per year, so minor. Let's switch that back off again. Okay. So again, so useful in terms of you actually are provided with a figure, but also perhaps more useful that you could use this to demonstrate the kind of potential savings you're looking at through rainwater harvesting. Now you're never going to really demonstrate that to the client in terms of cost, because the costs are very small, but in terms of sustainability there is a bigger benefit there. Okay, so that was water usage. Now let's look at our photovoltaic analysis. And again, what we're looking at is the potential electricity generation here from photovoltaic panels, and it looks at all the exposed surfaces across the building. It looks at the solar exposure, and it looks at the obstruction shading, so are they overshadowed, and calculates for the exterior walls, for the roof, for the shades, what the potential photovoltaic electricity production would be. And here what it's showing in green is what the payback would be in years. So how many years would you probably need to run this building to regain the cost of those photovoltaics? And what it's doing here is it's putting anything below 50 years in green. So obviously quite a long payback time. Okay. Right. So we've got that for all of the surfaces. You see along the bottom here, we're on page 2 of 10 now. What it's doing is it's ranking those surfaces, and you see when you get to some of the surfaces, it's saying that the energy collection would be negligible. It would take you more than 100 years to get the payback on that. If we go back to our first page, the sort of realistic ones, what it could be doing here is it could be advising you that these are the parts of the building that are likely to be the most efficient in terms of photovoltaic panels. Now, that is related back to the Revit model, and the ID would be referenced. You can find that ID in Revit. Right. You can change the panel type, but really, as a design tool, perhaps not worth doing that. More important to look at the potential. And here we have the cost of the panel, which you can change, the cost of electricity, and the max payback period. Again, you can change that and update. And here's the summary. Cost of installing those panels would be 308,000. That would give you 279 meters squared, which would produce 29,000 kilowatt hours per year, save you £4,000 per year, and overall 44 years payback. That's assuming that all these elements in green were utilised. Now if you change that, so if we change our max payback period to, no point changing it to 30 because we won't have any, if we change it to 45 and update, it's now only considering any surface where the payback period is less than 45 years. Okay. If you were in a climate with a more powerful sun, of course you would have better paybacks. And of course the technology is always changing. So if you wanted to put precise costs per watt produced, you could type that in here and update. Okay, let's get our lead daylight. And what we're now getting is, we've already seen this figure in our summary, that we are 66.3% of our spaces are achieving daylight factor of 2%. And here is where you get the breakdown. Okay. And again, what it's doing is it's highlighting in green all the spaces that are achieving more than our 2%. And you can then reference that across here to our rooms. So this would be very powerful actually as a design tool, because you can very quickly look across here, look at seminar room 111, and you could relate that back to Revit. Why is that not receiving adequate daylight? And that would very quickly point you that that room probably has the wrong window size. And you can look through the whole model. Obviously some of our WCs, circulations, spaces have no windows, so there's no daylight. And if we go to our second page, again it's storerooms. None of these rooms have windows, so there's no daylight. Go back to our first page now. For each of the rooms, we get some information, get the area, the side light, glazing areas, any skylights, which we don't have any. So we get those parameters, and we look here at the rooms which are achieving the correct daylight factor. For example, the cafe is 7.9% daylight factor, so that's performing fairly well. Okay, 3D VRML View gives you, it's quite a crude view this, you have to actually import a viewer, and that's different whether you're on a Mac or a PC. I'm not going to go into that because it's very crude, but basically what it's supposed to do is give you a 3D view of the file, which it does, but it's too crude to be any use to you, to be honest. Export and download data files. So here you can export the energy files as GBXML, VRML, Go2, Energy Plus. If you wanted to take it into a different software. Design alternatives. So here are all the alternatives that it's calculated for you. A lot of information there. You can go in here, you can change the parameters. Okay, have a look at that in your own time. Right. Let's go back to our own charts. Okay, so you've just got some more graphical analysis. At the top here, it's showing all the different alternatives that it's calculated. You have to hover over to be able to see it. It's not very user-friendly, that. But if you go to the bottom, it's slightly more easy here. You can change from your base model, which is the one that we've just looked at, and here we have energy usage throughout the year, electricity, fuel. That makes a lot of sense. That's in terms of cost. You can change that to energy, and yeah, change the units. Okay, back to cost, and you can then change that for some of the alternative designs. So let's change it for this one where the orientation is flipped to 90 degrees, and you get the alternative graphs for that. And probably a thing here to do would be to just do a screen capture here of the different options that you are testing. Okay, back up to the top. Oh, here's your code. Sorry, here's your color code, by the way, for the graphs. Project defaults, you know about. Project details. We've already put these in. Project members not really interested in that. Utility information. So here's the costs that we're using. And finally, along the top, weather station. And this is interesting to us because it gives us the weather parameters that Green Building Studio is pulling in for our site. So wind roses, wind speeds, humidity, temperature, sky cover, radiation. Unfortunately, it is using its American units. Okay. We've got some different parameters along the side here. So a lot of information there. Okay. So you can change what I did there was I just changed it from a yearly windrows to a winter windrows, and get data and pulls in that data. So that's all useful. Design conditions. Monthly temperature data, and you can download the weather data. Okay, so that's a very quick run through Green Building Studio. Now, as I said, I wasn't really intending on introducing this because I just find, if we go back into Revit, I just find that the energy analysis compare reports in many respects is a bit more user friendly because everything's there on display, whereas the Green Building Studio interface is perhaps just a little bit too complicated, but it does seem to be the only way at the moment to overcome this problem with the shading surfaces in Revit going into the DO2 engine. Having said that, they'll probably fix it next year, hopefully, and we won't have to do any of that. Okay, so in terms of your assessment, I think really it's up to you. You can run your energy analysis from the building model that I've provided. It works perfectly well from Revit. up to the point that you import it into the site. Now obviously if you run it without the site, you're not getting all of the parameters of the surrounding buildings, but it will still give you a reasonable level of analysis, and you could try some design alternatives there. If you want to then bring the model into the site in Revit, it would appear you will have to go through the GBXML export route and importing that into Green Building Studio. If you want to try other energy analysis packages, you could of course at that point import that GBMXL file into Ecotext or into another package, but I'm not covering that in this tutorial. Okay, so we'll end it there. As I've said many times, the important thing about this course is for you to become familiar with the idea of simulation and using it as a design tool. The actual software will continue to change, and probably in 5 years' time we'll be using a completely different interface. Okay, I'll end it there. If you've got any questions on it, then by all means drop me an email.